Today we're going to be talking about the properties of logarithms. But before we even get started with that, I want to remind you, logs are exponents, exponents are logs. So before we can talk about the properties of logs, we need to review the laws for exponents, because logs are exponents, exponents are logs. When we multiply with the same base, that would be like taking x cubed times x to the fourth, which would give me x to the seventh. The shortcut is we add exponents. When you divide with the same base, like n to the 5 over n squared, that would give me n cubed. The shortcut, you subtract exponents. A power of a power would be something like x to the fourth raised to the fourth power, and you multiply your exponents. 4 times 4 is 16. So you multiply the exponents. And finally, a power of a product. A product means you're multiplying two factors or more than two factors together, raising it to a power, and that would be x cubed times x to the third. You take the power of each factor. Now, let's start looking at the properties for logarithms. Let b, u, and v be positive numbers such that b is not equal to 1. The product property works like this. You have the log base b of u times v, and that's equal to the log base b of u plus the log base b of v. The way you want to remember this is from your exponent laws. Here I'm multiplying with the same base, and when you multiplied with the same base, you added exponents, and that's just what's happening here, because logs are exponents. The next property is the quotient property, and it looks like this. Have the log base b of u divided by v is equal to the log base b of u minus the log base b of v. It's the quotient law. Now notice here what I'm doing is I'm dividing with the same base. When you divide with the same base, here's another example. N to the 7th over n to the 3rd is equal to n to the 4th. I subtracted the exponents. Well, logs are exponents. So when I divide with the same base, I'm going to subtract the exponents. Subtract the exponents. The power property. Log base b of u to the nth power is equal to n times the log base b of u, the power property. The n comes out in front, n times log u base b. Logs are exponents. Here's some examples. Now, with a problem like this, you would not be able to use your calculator, but you would have to be given something, because you can't get this in your head. The log base 7 of 3 is approximately 0.565. Log base 7 of 2 is approximately 0.356, and the log base 7 of 5 is approximately 0.827. That would have to be given to you. But now, just by using the 3, the 2, and the 5, somehow I need to rewrite 6 by using those laws that we just talked about. Well, 6 is 2 times 3. So this would be the log 7 of 2 times 3. And this goes back to the product property. When I multiply with the same base, I add my exponents. So log base 7 2 plus log base 7 of 3, which is, and now I'm going to substitute these numbers that I have that were given to me. 356 thousandths plus 565 thousandths, which gives me 0.921. Here's another example. Same 3 logs were given to me, and now I need to figure out how I can write 125 by using only 3's, 2's, and 5's. Well, the way that I can do that is I can rewrite 125 as 5 cubed. 5 times 5 times 5 is 125, and now I can use the power law, the power property. 3 comes down over here, 3 times the log base 7 of 5, which is 3 times log 7, or log 5 base 7 is going to be 0.827, which is equal to 2.481. Here's our next example. Find the log base 7 of 21. Remember again, I have to be given this ahead of time, and somehow between a 3 and a 2 and a 5 I need to be able to write 21. Well, that would be the same as log 7 that would be log 7 3 times 7. Now I just said you have to have 3, 2, and 5, and now I'm putting a 7 there. But notice that the base is a 7. Watch this. I could say that's log 7, 3, plus, by using the product property, log base 7 of 3 plus log base 7 of 7. And do you remember this? I'm going to write this over on the side. This was in the last set of notes. If I set that equal to x, then I would have 7 to the x equals 7. Well, there's got to be a 1 there, so x would have to be 1. So this is 1. So now I have 0.565 plus 1 is equal to 1.565. Example number 4. 8 is the same thing as 2 cubed. And I've got the 3 and I've got the 2, and actually I don't even need this, because I'm going to say that's 3 times the log base 7 of 2, which is 3 times 0.356, which is equal to 1.068. Example 5, 30. Okay, remember I can use 3's, 2's, and 5's to rewrite 30. So this is log base 7. 30 is going to be 2 times 3 times 5. So I use my product property. Remember, logs are exponents. When I multiply with the same base, I add exponents. So this gives me 0.356 plus 0.565 plus 0.827, and when I add all of them up, I get 1.758. Product property again. 14. Well, I've got 3 and 2 and 5, but if you think back a couple examples, I can also use 7. So I'm going to have log base 7, 2 times 7. Now I'm going to use the product property, log base 7 of 2 plus log base 7 of 7. This is given, the approximation is right here, 0.356 plus, and remember, anytime these numbers match, that's going to be 1. So 1.356. The next type of problem is when we need to expand a logarithm. So this says expand log base 2 of 7x cubed divided by y, and assume that both the x and the y are positive numbers. So I want to break this apart using the properties that I just had. So first I'm going to break apart the 7x cubed and the y, and that's dividing with the same base. So I have log base 2 7x cubed minus log base 2 of y. Now I can separate this. These are two factors, 7 and the x cubed. So I can use a product law. Remember, when I multiply with the same base, I add the exponents. Don't forget to copy this back down. The only thing that I can do now is I can change this so I don't have that exponent of 3 by using a power law. So the 3 comes out in front. So it's 3 log base 2 of x minus log base 2 of y. Let's try another expanding problem. I'm multiplying with the same base, so I want to add my exponents. Whoops, that was supposed to be a 5. Plus, here's a power law that I can use. The 6 comes down in front. And there we go. That's all I can do on that one. Now, besides expanding, I can also condense my problems. So, condense my expressions. So here, just like the last thing that I did on this problem was I did the power law, I'm going to do the same thing here, only backwards. When you have a coefficient in front of a log, what you can do is raise it to that power then. Now, you might think that I forgot the base here. I hope you remember, this is a common log. When there is no base, what it really is a 10. It's just that nobody ever writes that with a common log. 2 squared is 4. Now, I'm adding the exponents. Remember, logs are exponents. When you multiply with the same base, you add the exponent. So I can multiply the 6 and the 4. And when I subtract exponents, that's when I'm dividing with the same base. So this would be the log of 24 over 3, which is the common log of 8. Our next problem is to condense this expression. Here I have another power law. So this would be the log base 3 of 7 squared minus the log base 3 of x to the 5th. 7 squared is 49, and then this I can't do anything with this. And now I will be dividing because I'm subtracting, and remember, when you subtract with the same base, or when you divide with the same base, you subtract exponents. So my final answer with this problem is going to be the log base 3 of 49 over x to the 5th. Now we're going to evaluate a log without estimating. We're going to use our calculator. So we're going to use the change of base formula. So let a, b, and c be greater than 0 with b not equal to 1 and c not equal to 1. Then log base c of u is going to be equal to log u base b over the log c base b. Now notice these two bases are the same, and it doesn't matter what you use. Now we're going to use the calculator for this because our common base, our common log is 10, and that's right on the calculator. That's the LOG button. And we also have the natural log, which is the LN. So if I'm going to evaluate this, I could do the natural log of 16 divided by the natural log of 9, which will give me 1.62, or I could do the common log of 16 over the common log of 9, which still gives me 1.262. And I just got under 15 minutes. Have a great day.